Would you rather watch paint dry than read an organic chemistry textbook? Well, today's your lucky day. As it turns out, oil paint doesn't just simply evaporate to dry. It actually undergoes some pretty cool chemical processes that I'd love to show you. So, what do you say? Ready to watch paint dry?
A drying oil, such as linseed or walnut oil, is combined with colorful pigment to create oil paint. Oils are esters, meaning they're the combinations of an alcohol and carboxylic acids. Drying oils specifically are composed of glycerol and unsaturated fatty acids. Fatty acids contain a carboxyl group, hence why they're carboxylic acids attached to a carbon chain. The carbon chain is unsaturated, meaning some carbons won't be attached to the maximum number of hydrogen atoms possible. We'll see why this is important later. Each hydroxyl group on the glycerol is an attachment site for a fatty acid chain, and that makes one molecule of drying oil that can be mixed with pigment to form paint.
The drying process of oil paint consists of two parts, autoxidation and cross-linking.
In this context, autoxidation is when oxygen molecules join onto the carbon chains of the oil. First, a free radical, a highly reactive unpaired electron, will need to abstract or take away a hydrogen atom so that the carbon can bond with oxygen. Free radicals can come about in many different ways. For example, a common allotrope of oxygen contains two free radicals. But out of all these hydrogens, which one will be abstracted? This is where the unsaturation in the carbon chain comes into play. CH bonds next to unsaturated carbons contain less energy, so they're easier to break, meaning the hydrogens can be more easily abstracted. When the carbon bonds with an oxygen molecule of two free radicals, there's a free radical on the end. This chain can now abstract a hydrogen atom from another chain, leaving a free radical behind each time, and the chain reaction, no pun intended, continues. Now, let's look at the next part of the process, cross-linking. Here, OH slowly detaches from the group, leaving one remaining oxygen with a free radical, so it's super reactive. Over time, the same process occurs in all the other chains as well. Each oxygen becomes an attachment point where the carbon chains link together, and gradually, the drying oil forms a cage that traps the pigment molecules, ensuring that the color will stay in place. The paint is now dry.
Unfortunately, the drying process of oil paints can also emit volatile organic compounds, or VOCs, which can be harmful to humans and the environment. Scientists have been working for years to figure out ways to mitigate this. But maybe you, yes, you right there, could be the one that finds the perfect solution to this. You're probably going to need to open that organic chemistry textbook first, though. But hey, if something as boring as literal paint drying can be fascinating at a chemical level, maybe other chemical processes could be too?